Hey, welcome. What we're going to do today is we're going to learn how to graph quadratic equations, and we're going to learn how to graph quadratic equations that are written in standard form. And the standard form of a quadratic equation, you can see in the goal, is it's any equation that can be written in the form ax squared plus bx plus c. So to begin talking about how do you graph a quadratic equation that's written in standard form, let's go ahead and talk about what the shape of that graph is going to be first. And I've given you a couple of examples, and then we can talk about the more specific methods used to actually create the graphs. The shape of a graph of a quadratic function you ought to know is called a parabola. And I've got a couple of examples of parabolas. I've got a parabola here that opens upward. All right, parabolas are often described as U-shaped. And I've got a parabola that opens downward as well. And so, first thing I want you to know is that if I'm looking at this quadratic function in the standard form, there's an easy way to determine whether the graph will open up or open down, and that's just simply using the value of a. This value of a will tell you which way the parabola opens. And it's as simple as, is a positive or is a negative? Whenever a is positive, greater than 0, you're going to get an upward facing parabola, such as you see on the left. And whenever a is negative or less than 0, you're going to get a downward facing parabola, such as you see on the right. Now, by the way, what happens if a is equal to 0? Well, it turns out a cannot be equal to 0. Because if a were equal to 0, then you wouldn't have a quadratic term at all, would you? Because you'd have 0x squareds. And then you would just have a line, because you'd have an equation in the form bx plus c. All right, so here's a is greater than 0. Here's a is less than 0. Now, there's some key features that you need to know about the graph of a parabola. One of those is simply that a parabola is symmetric, isn't it? You could imagine drawing a vertical line in which these two halves of the graph are reflections of one another. And so that vertical line, which I'm going to draw right now, and that's simply called the axis of symmetry. All right, now what we're going to be able to do, it turns out, is we're going to be able to use the coefficients that are in the standard form in order to calculate where that axis of symmetry would be located. One of the most important things in graphing a parabola is knowing where the axis of symmetry is. Okay, so the coefficients I was talking about. It turns out that the values of a and b will help you locate the axis of symmetry, and you just have to use this little formula that we'll discuss more in depth at a later time in this chapter. X equals the opposite of b divided by 2a. That will get you the equation of the axis of symmetry. Now, it is a vertical line, and you'll remember that the equation of a vertical line is always in the form of x equals some number, and that number, it just happens to be the opposite of b over 2a. Okay, so for instance, this kind of looks, even though I didn't actually give scale to this graph, kind of looks like the line x equals 1 or x equals 2, something like that. Okay, so there's how you calculate the axis of symmetry, and you do that the same way if the parabola opens downward as you do if it opens upward. All right, the direction doesn't matter, it's just here's how you find the axis of symmetry's equation. All right, another key feature on the graph of a parabola is its vertex. You're going to notice that each of these parabolas has either a minimum point in the case of the upward facing parabola or a maximum point in the case of the downward facing parabola, and these points are the vertex. They're each called the vertex of the parabola. And now, in order to get you to understand what we're going to do to calculate or to find the coordinates of the vertex, here's the first thing I need you to know. The vertex is always going to be located on the axis of symmetry, right? It's located on the axis of symmetry here. This will be the vertex. It's located on the axis of symmetry there. The vertex is always located on the axis of symmetry. And so the reason that's important to understand is because we can use the equation of the axis of symmetry in order to figure out what the x-coordinate for the vertex is. All right, so the x-coordinate for the vertex simply corresponds with the equation for the axis of symmetry. It would simply be the opposite of b divided by 2a. All right, now how about the y-coordinate for the vertex? Well, if you know the x value for a point and you want to find out what is the y value that would go along with that point for a given function, what you do is you substitute that x value into the equation, right? So if this x coordinate was 2 and I wanted to find out what's the y coordinate, I would plug in 2 into the function and it would tell me the y coordinate. Now, whenever you're trying to show that you're substituting a specific value in place of x, using function notation, you just replace x with 2 or -6 or whatever you want to plug it in for, right? Well, I want to find out what the output value is when I plug the opposite of b over 2a into the function. And so I'm simply going to write that as being f of the opposite of b over 2a. Now that might look confusing right now, but you'll see it in action here pretty soon, and it's actually a pretty simple thing. It's just take the x value that you get from the axis of symmetry and plug it into the formula to get the y value that corresponds with it. All right, so that's how you locate the axis of symmetry and the vertex. One other key thing that you'll want to be able to do with the standard form in order to be able to graph an equation is you'll want to be able to find out what is the y-intercept. All right, x-intercepts are helpful as well, but you need to know a little bit more in order to make those happen. But you should be able to find the y-intercept, and the y-intercept is super easy to find. And in fact, you already know how to find y-intercepts for lines, but we can apply the same principle to finding y-intercept for any function, it turns out. If I'm trying to find the coordinates of this point where the parabola intersects the y-axis, I know first of all that the x coordinate for that point has to be 0, correct? Which then means in order to find out what the y coordinate for the y-intercept is, all I need to do is plug in 0 for x in the equation that I'm given. And if I plug in 0 for x, I would get 0x squared plus 0x plus c. And that's just 0 plus 0 plus c. The y coordinate for the vertex simply corresponds with that value c. All right, so what I need you to take away from this slide is that this is how you calculate the equation for the axis of symmetry. This is how you calculate the coordinates for the vertex. And this is how you calculate the y-intercept. One other thing. Why is the y-intercept important? Well, in order to make the graph of the parabola, we're going to take advantage of the fact that it's symmetric. And so whenever we can figure out what the y-intercept is, we can simply reflect the coordinates of the y-intercept in the x-axis in order to create the corresponding point on the opposite side of the axis of symmetry. All right, great. Now let's do a couple of examples. Let's begin with this example. F of x is equal to x squared plus 7x plus 12. Now my goal here with this example was to talk you through the process that you need to go through in order to graph a parabola. All right, I'm going to mention some of the same key features that I mentioned a moment ago and show you how to apply it when you're given the equation of a quadratic function. In order for any of that to matter, one of the things that you're going to have to do is you're going to have to be able to find the values of a, b, and c. Now, a is always going to be the coefficient for your quadratic or your x squared term. Now, that's a 1x squared right there, so that means our a would be 1. b is always going to be the coefficient for your linear term or your x to the first power term, and that coefficient's 7, and we'll call it positive 7 because of the addition sign in front of it. And then c is always going to be the constant term within your quadratic function. And so c is going to be equal to 12. All right, now the process for making our parabola. Where I'd like you to begin with that is first of all thinking about, will this parabola open upwards or downwards? And we said a moment ago that that's determined by whether or not a is positive or negative. A is positive here, so that means we're going to have a parabola that's going to open upward. All right, so we know it opens up instead of down. That's important. The next thing we need to do is we need to think about where are the key features of the graph that would make it easier to graph. Axis of symmetry is the first of those that you need to be able to calculate. And I gave you a formula for how you find the equation for that axis of symmetry. And that formula is that x is equal to the opposite of b over 2a. Well, so let's use the values of a and b that we found from the equation, and let's plug those in. So we would say x is equal to the opposite of 7. So There we go, the opposite of b, divided by 2 times a, so that's 2 times 1. Now that's going to give me negative 7 divided by 2, and negative 7 divided by 2, of course, is approximately, well, not approximately, it's exactly negative 3.5. So the equation for my axis of symmetry is x equals negative 3.5. And what I'm going to do now is I'm going to go ahead and sketch the graph of the vertical line with that equation. And as you'll recall, whenever you're graphing a vertical line, given its equation, this means you know its x-intercept. So we would go over to negative 3.5 here and just draw a vertical line through that x-intercept. So here's that line. And even though this is not actually part of the graph, it's going to help us see how to make one of the halves of the graph. It kind of helps us know where the graph is centered around, if you will. It's very important to draw the line so that you kind of have a good picture of what the rest of the graph is going to look like. Okay, so after we identify what the equation for the axis of symmetry is and we graph that, the next thing we're going to do is we're going to try to figure out where are some important points on the parabola, the most important of which is the vertex. And what we said you do to find the vertex is you plug the coordinates, the x-coordinate for the axis of symmetry, into the function. In this case, that means we're going to find f of negative 3.5. So let's substitute negative 3.5 in place for x. That's going to give us then negative 3.5 squared plus 7 times negative 3.5 plus 12. Now, be careful, follow order of operations here. I'm not going to do these calculations out loud for sake of time in this video, but follow order of operations. And when you do, you're going to find that f of negative 3.5 is negative 0.25. Which then tells me that the coordinates of the vertex are negative 3.5, comma negative 0.25. So there you have it. Now I'm going to go ahead and plot that. Actually, I'm going to hold off on plotting that, and I'll tell you why in a moment. But there is one other piece of information I'd like to figure out or determine about the graph of this parabola before I try to actually sketch the graph. And that is, I need two other points on the graph. I need one point that's going to be on the right side of the axis of symmetry and one point that's going to be on the left side. And the easiest point to find typically is the y-intercept. And so I'm going to go ahead and find the y-intercept for this graph. And we said that you can find the y-intercept simply by plugging in 0 for x, or even better, just recognizing that the constant term, the value of c, is always going to be the y-coordinate for your y-intercept. So 0, 12 is our y-intercept. Now, I held off on graphing the vertex because I knew this would be a possibility. I knew that I might care to change the intervals on my y-axis. When you're squaring numbers like we are in this function to calculate outputs, you can get some really large values really quickly. So it would not have made sense to go ahead and assume I was going to go by ones here. And in fact, I'm not going to, because I'd like to be able to show this point 0, 12, and I won't get there by ones. Now, you're going to have to change your intervals quite frequently with these quadratic functions and other functions that we'll be graphing throughout the rest of the year. And so when you change the scale, you need to indicate on your graph what your scale is, and I've just done that here. I put a 2 right here on the x-axis to indicate that I'm going by ones. Now, this is 1, this is 2, this is 3, this is 4. And I decided to go by 2's on the x-axis, so I labeled the 4 right there, and that means this is 2, 4, 6, 8, 10, 12, and so forth. Okay, now I should be able to plot the vertex, negative 3.5, negative 0.25, and I'll just plot that right there on the axis of symmetry, because the vertex is always on the axis of symmetry. Right about here would be where I want to plot that. Then, of course, the vertex, sorry, not the vertex, but the y-intercept, that's 4, 6, 8, 10, 12, right there is going to be my y-intercept. And so right now I can go ahead and make half the graph of the parabola. Remember, the parabola is not a V shape, it's a U shape, and so something like that would be sufficient. And also, I want you to show me that you understand that the graph would continue beyond what you drew. Now notice I didn't draw this thing going directly straight up. I didn't curve it back inwards. The curve is continually going off to the right and up. Okay, so that's half of the parabola. How do I make the other half of the parabola? Well, the other half of the parabola is going to be created by utilizing the fact that parabolas are supposed to be symmetric. All right, so I know a point that's on the right side of the parabola, and I also can see that that's 3.5 units away from the axis of symmetry. Well, that means its image, or what I would get if I were to reflect this curve in the axis of symmetry, would be 3.5 units on the other side. So right here then would be the corresponding point to that x-intercept, and I'm going to go ahead and graph that. Okay, you see how these 2 points are equidistant from the axis of symmetry. And then all I've got to do is draw the curve for the left side of the parabola. And there you go. That's how you graph a parabola. Now I'd like to do one more example with you, but you see the process. Does it open up or down? Where is the axis of symmetry? Where is the vertex? And where is the y-intercept? Then you go ahead and make your graph. So let's graph this equation as well. Also, I'm going to try to go a little bit more quickly through this example so the video can end in a reasonable amount of time. But let's go through the process. Remember, first thing you need to do when given the equation of a quadratic function or an x squared function is you need to go ahead and determine what the values of a, b, and c are, and those will be -2, -8, and -1 respectively. Alright, then you want to determine will the graph open up or down. Since a is negative, we know that this graph is going to open downward. Alright, and now it's time for the axis of symmetry. Remember, you use the formula x equals the opposite of b over 2a. So in this case, that would be the opposite of -8 divided by twice -2. That's my 2a. And that is really just +8 over -4. And +8 divided by -4 is -2. There's your equation for the axis of symmetry, which I will now be graphing. Again, to graph that, go to the x-intercept of the line, -2, and then just go and draw a vertical line through it. Now for the vertex. So remember, this is going to be the x-coordinate for the vertex, and we're going to substitute its value into our function in order to figure out the y-coordinate for the vertex. So you're finding f of -2. Let me show the work for that right now. And here's one where I would like to talk you through the order of operations. If you look at all the operations here in this expression, squaring is the first thing we've got to do. So we're going to square this -2 and get 4, but we still have the -2 in front of that. That's going to be -2 times 4. Now for the next term, I'm going to go ahead and multiply the -8 and -2 and get 16. And then we got the -1 at the end. And so that's -8 plus 15, and that's going to be 7. So the vertex then is going to be the point -2, 7. Then the final piece of information that I'm trying to determine about the graph, if you'll recall, is where is its y-intercept. And the y-intercept is going to be the point 0, c. And the point 0, c then is going to be 0, -1. Alright, so looks like my scale, since I just have to show -2, 7, and 0, -1, I can go by 1s on the vertical axis as well as the horizontal axis, of course. So let me do that and plot these 2 points. Alright, there's the vertex there at -2, 7. The y-intercept at 0, -1. Then make the smoothest curve that you can going through there. It's going to continually go down and to the right as such, and we'll put an arrow there. And then we've got to make the opposite half of the graph. And remember, the way you do that is you take advantage of the symmetry. Typically, I'll do this with the y-intercept. The y-intercept happens to be 2 units away from the axis of symmetry, so its image will be 2 units on the other side right here. Let me go ahead and plot a point there. And through that point, then, I can draw the left side of this graph. And here's what that would look like then. There you go. You know now how to graph the equation of a quadratic function, or how to graph of a parabola, if its equation is given to you in the form ax squared plus bx plus c, also known as standard form. Thank you for your attention, guys. Hope this graphing goes well for you. I'll see you next time.